This video, we will look at 3 examples of multiplying and dividing rational expressions. Here we are asked to multiply 4n to the second power plus 3n minus 10 over 2n to the second power plus 3n minus 2 times 2n minus 1 over n plus 4. So we are to multiply two rational expressions. Now, when you multiply fractions, you multiply the numerators, you multiply the denominators, and then you simplify. What we're going to do is simplify first and then multiply numerators and multiply denominators. In order to simplify, we must factor. So we need to factor 4n squared plus 3n minus 10. And you can see here it factors into 4n minus 5 times n plus 2. We also are going to factor 2n to the second power plus 3n minus 2. And it factors into n plus 2 times 2n minus 1. 2n minus 1 over n plus 4, neither of these two terms factor, so we leave them as is. Now when we multiply, again, we multiply all these together. So this turns into one big fraction. What that means is any matching factor on either of these two numerators with either of these two denominators is the number 1 in disguise. So basically all I'm looking for, do I have the same factor in the numerator anywhere that I do in the denominator? And in this problem, yes, you do. So n plus 2 over n plus 2 is the number 1 in disguise. So is 2n minus 1 over 2n minus 1. We cancel those and end up getting 4n minus 5 over n plus 4. In this example, we're dividing. It still comes down to factoring and canceling. However, with dividing, you need to remember that when you divide fractions, you change the divide to multiply, and we use the reciprocal of the second fraction. So before we do any factoring, we need to change the divide to multiply and write the reciprocal of the second fraction. Now we've changed this into a multiplication problem. So we factor, look for matching factors so we can cancel. So here's the factorization of our numerator, 5z minus 1 times z minus 3. Here's the factorization of our denominator, z plus 4 times z minus 3. 2z cubed plus 8z factors by taking a greatest common factor out. Now, instead of writing 2z to the second power, they went ahead and wrote 2z times z to make it very obvious that there will be something you can match and cancel with in the denominator, because this denominator also factors by taking a greatest common factor out. You can take a 6z out. Now, if you notice, we've got a 5z minus 1 that we can match with a 5z minus 1. We've got a z minus 3 that matches with a z minus 3 in the denominator. We have a z plus 4 and a z plus 4. And then we have this 2z here. So most of these terms cancel, and what we're left with is z over 3. Here's one more example. X squared minus 1 over x cubed minus 1 times xy minus 2y plus 3x minus 6 over xy plus 3x plus y plus 3. This example is a good one to look at because there are 3 different types of factoring here. First, we have the difference of squares. So x squared minus 1 factors into x plus 1, x minus 1. X cubed minus 1, that's the difference of cubes. So that's going to turn into x minus 1 times x squared minus x plus 1. Then we have factoring by grouping in both this numerator and the denominator. So we have factoring by grouping halfway done up here. Notice there's an x minus 2 in both these terms. In the denominator, there's a y plus 3 in both the terms. So finally, we have our complete factorization here. And again, we're looking for matching factors. Here's the number 1 in disguise, x minus 1 over x minus 1. Here's another number 1 in disguise, x plus 1 over x plus 1. And a third number 1 in disguise, y plus 3 over y plus 3. So at the end, we end up with x minus 2 over x squared plus x plus 1.